In this lesson, we are going to be covering solving systems of equations using the elimination method. So, before we just jump right into some examples, there are some steps that we need to follow in order to do this elimination method correctly. The first one, we want to ensure that both equations are in standard form. So, if they're not, you could always transform them into standard form, or you could consider using one of the other methods. Maybe the substitution method would be better. Okay, step number two, we're going to multiply one or both of the equations by a value to get the coefficients of either x or y, it doesn't matter, to be opposite integers. Step number three, we're going to add those equations together, and this is going to eliminate either the x or the y variable. Step number four, you're going to solve the resulting equation. And then step number five, we want to substitute that value back in to one of the original equations to solve for the other variable. Okay, I know that sounds like a lot right now, guys, but as we walk through our examples, hopefully those steps will become clear. All right, let's take a look at our first example. It says 2x plus 3y equals 6, and x minus 2y equals negative 4. Notice that both of these equations are in standard form, so the elimination process is perfect. The coefficients of x right now are 2 and 1. The coefficients of y are 3 and negative 2. So what we want to do is multiply one or both of the equations by values in order to get those coefficients to be opposite integers. So there's many ways that you can do this, but the easiest way that I see is we're going to multiply this bottom equation. Since the lead coefficient is just 1, if I need the x coefficient to be the opposite integer, I technically need a negative 2 there. So I'm going to multiply this bottom equation by that negative 2. Because negative 2 times 1 would give me that coefficient that I need of negative 2. So let's go ahead and multiply that whole bottom equation by negative 2. Negative 2 times 1x is going to give me negative 2x. Negative 2 times negative 2y is going to give me positive 4y. And negative 2 times negative 4 is going to give me positive 8. Now, the top equation, since it has a 2x, we don't have to multiply it by anything. So I'm just going to pull it straight over. Right now, the coefficients of x are opposite integers. One is positive 2 and one is negative 2. That's what we want. We want the coefficients of either x or y to be opposite integers. All right. Step number 3, let's go ahead and add these two equations together. 2x plus negative 2x, those eliminate, hence the elimination method. 3y plus 4y gives me 7y. And 6 plus 8 gives me 14. The next step, we solve this equation. So divide both sides by 7. And we get y equals 2. The last step in this process is to plug that value back into one of the equations. I'm going to pick the x minus 2y equals negative 4 equation. So I'm picking this bottom equation. All right, we know that y is 2, so let's substitute 2 in for y. This equation would say x minus 2 times the y value, which we just found was 2, is equal to negative 4. And we're going to solve that equation for x. So 2 times 2 is 4, so x minus 4 is equal to negative 4. And we solve that for x by adding 4 to both sides. All right, we get x on the left side And negative 4 plus 4 makes 0. So our point of intersection, or our solution to this system, is at the coordinate 0, 2. Remember to put those in order, x, comma, y. So that is the solution to this system using the elimination process. All right, let's take a look at another example. Okay, this example says 8x plus y is equal to negative 16, and negative 3x plus y is equal to negative 5. Again, these are both in standard form, so it's set up perfectly for elimination. If I take a look at the coefficients of x, I see 8 and negative 3. So, one, they are not opposite integers of each other, and there's nothing I can multiply 8 by to get 3 nicely, and there's nothing I can multiply negative 3 by to get 8 nicely. So let's look at y instead. Right now, the y coefficients are both 1. So they're the same integer, but they're not opposites. So let's multiply one of the equations by negative 1. I'm going to pick the bottom one. It doesn't really matter which one you picked, so you could have picked the top if you'd like. The top equation is going to stay the same, so I'm just going to pull that over. 8x plus y is equal to negative 16. The bottom equation, remember, we're multiplying that by negative 1. So if we distribute that negative 1 to everything, it's going to switch all the signs. Negative 3x times negative 1 gives me positive 3x. Negative 1 times positive y gives me negative y. And negative 1 times negative 5 gives me positive 5. Okay, let's go ahead and add these two equations together. 8x plus 3x gives me 11x. The y's eliminate. And negative 16 plus 5 gives me negative 11. Solving this equation for x, we get x equals negative 1. Last step, we have to solve or substitute this value back into one of the original equations. I'm going to pick the top equation this time. 8x plus y is equal to negative 16. So let me write that equation down first, I guess. And we're substituting in negative 1 for x. So 8 times negative 1 plus y is supposed to equal negative 16. 8 times negative 1 is negative 8. And to solve that equation for y, we are going to add 8 to both sides. So we get y equals negative 8. Again, we want to write the solution as a coordinate point. So the x value is negative 1 and the y value is negative 8. So negative 1, negative 8 is the solution to this system. Okay, here's the next example. We have negative 4x minus 2y is equal to negative 12. And 4x plus 8y is equal to negative 24. Step number 1, they're both in standard form, so again, perfect for the elimination method. Step number 2, we need to check that the coefficients are opposite integers. And hopefully we notice right away that the coefficient of x on the first equation is negative 4, and on the second equation is positive 4. So we already have opposite integers. So we don't need to multiply by anything. Let's just add these two equations together. Negative 4x plus 4x, they eliminate. Negative 2y plus 8y gives us 6y. And negative 12 plus negative 24, that gives us negative 36. Dividing both sides of the equation by 6, we get y equals -6. Again, we're going to plug that into one of the original equations. I'm going to pick equation number 2. 4x plus 8y is supposed to equal -24. We know y is equal to -6. So 4x plus 8 times -6 is equal to -24. 4x minus 48 is equal to -24. Adding 48 to both sides, we get 4x is equal to +24, and dividing both sides by 4, we get that x equals 6. So the solution to my system is 6, -6. Again, making sure that we put the x value first and the y value second. So there's the solution to my system, 6, -6. Okay, here's the next example. Our two equations are both in standard form already, so this is perfect for elimination. If we check the coefficients are not opposite integers, so we are going to have to multiply at least one of the equations by values to get them to be opposite integers. Notice that the x integers are, or the x coefficients are both negative. The y coefficients, one is already positive and one is already negative. But I need to figure out if I can multiply 8 by something to get 9, or 9 by something to get 8, or maybe I have to multiply both of the equations by a value to get those coefficients to be opposite integers. And that's the case with this one. So the easy thing to do here, guys, is multiply the top equation by whatever the coefficient is on the bottom equation. So my coefficient on the bottom equation is 9. Multiply the bottom equation by whatever the coefficient of the top equation is. However, the coefficient of the top is -8. If I multiply the bottom equation by -8, it's going to give me a negative here, and they're no longer going to be opposites. So I'm going to multiply the bottom equation by +8, so that way the top equation is going to have a negative coefficient for y, and the bottom equation is going to have a positive coefficient for y. Again, remember, we want opposite integers. So again, I'm multiplying that bottom equation by +8. We are going to have to distribute both of those equations. So the top equation, we're distributing 9 through, so we would get -63x minus 72y is equal to 81. The bottom equation, we're distributing the 8, so we get -32 plus 72y is equal to -176. Hopefully I multiplied that correctly in my mind. I think so. Okay, let's go ahead and just double check. Are our coefficients of y opposite integers? Yes, -72 and +72. They are opposite integers. So we can go ahead and add these two equations together. So -63 plus -32, that gives me -95x. The y's eliminate. And we have +81 plus a -176. We get -95. Dividing both sides by that -95, and we get x equals 1. plugging that back into one of the equations. Doesn't matter which one I pick. I'm going to pick the bottom equation. That would say -4 times 1 plus 9y is equal to -22. Solving that, -4 plus 9y is equal to -22. Adding the 4 to both sides, we get 9y equals 18. And dividing both sides by 9, we get y equals 2. So again, the solution to my system is at 1, 2. Okay, this last slide is going over some special cases that could happen when you are doing the elimination method. And I just noticed there's a typo on this screen. That minus sign should not be there. So first of all, with this first example, we are going to multiply the top equation by 5 and the bottom equation by 2. That gives me 10x plus 40y is equal to 30. Okay, actually that typo, ladies and gentlemen, that was supposed to be a 20. Sorry about that. So when we multiply through by 2, we get -10x minus 40y is equal to -30. Okay, when we add these two equations together, 10x plus -10x, they eliminate. 40y minus 40y, they eliminate. So right now on this left side, we have 0 equals 30 plus -30 is 0. Notice that everything eliminated. So for this particular example, we look at what's left, and it says 0 equals 0, which is a true sentence, a true statement. So if it is true, we're going to say it has infinitely many solutions. Okay, next example, we're going to multiply the top equation by -2. We get -2x minus 2y is equal to -8. Bottom equation, I am just going to pull over. No multiplication is necessary there. So if we add them up, -2x plus 2x eliminates. -2y plus 2y, again, eliminates. So we get 0 on the left side. But this time on the right, -8 plus -12 gives me -20. Well, 0 does not equal -20. So this is a false statement. If you get a false statement, that means there is no solution. So hopefully you guys remember from the first day of systems, we talked about the different types of graphs that you could get. Most of the time, you're going to get two lines that intersect, and that's where we get that point of intersection. So we get one solution, and it's located at that coordinate point. But remember, we could also get parallel lines that would have no solution. So that was the case over here. The second set of equations, they were actually parallel. And then we could get one line that falls directly on top of another line, and that would be infinitely many solutions. And that was the case with this example on the left side. Okay. We are at the you try slide. So pause the video here, see if you can solve both of those examples using the elimination method, and then unpause the video when you're ready for those solutions. Okay, with this first example, we could just add the two equations together because the coefficients of x's were already opposite integers of one another. So when we add those two equations together, we get y equals -1. I chose the bottom equation to plug that back into. So 6 times x plus 4 times the -1 is supposed to equal -10. Solving that, I got x equals -1. So my solution to this system is -1, -1. The second example, we weren't quite so lucky. So we had to multiply both the top and the bottom of the equations by values to get the coefficients to match. I chose to try to eliminate the y's. So I multiplied the top equation by -5 and the bottom equation by +2. That gave me -15x plus 10y is equal to -10. And distributing the 2 through gave me 10x minus 10y is equal to 20. Adding the two equations together, we get -5x equals 10, so x equals -2. I chose the top equation this time to plug that value back into. So 3 times the -2 that we just found minus 2 times y is supposed to equal 2. And solving that equation for y, we get y equals -4. So my solution is at -2, -4. All right, this concludes the lesson on elimination.